Hello and welcome to How Coco channel. In this video, it's going to be a part 2 video of enzymes. We're going to talk about properties of enzymes, their activity with the external factors. If you want to know more about enzymes, how they work, all the basic information of enzymes, you have to head on to part 1 video, of which link I will put in the description box below. So first things first, there are 6 properties of enzymes. First one is that they all are proteins. These enzymes are biological catalysts. They are made of proteins. Even though it's weird that they digest proteins, their nature is different, which you will, I think, learn in A levels. Right now, it's not your focus. For scoring well in the exam, they won't ask that question. Number 2 is that they become inactive at high temperature. The thing is, they are protein molecules. So at high temperature, what happens is that their shape, we know that they have a proper shape, and it's so important. At high temperature, the shape gets altered. The shape, it changes. So basically, it no longer has the correct active site shape. And therefore they won't form an enzyme substrate complex. Next, number 3, they work best at a particular temperature. For example, in a human body, most enzymes, they work best at about 37 degrees Celsius. I mean, all enzymes, I would say. Enzymes works best at about 37 degrees Celsius in human body. Please excuse my handwriting. Number 4, they work best at a particular pH. What is pH? Now, pH is the scale of acidity from 0 to 14. Let me write down the definition. It is a scale of acidity from 0 to 14. So sometimes they are color coded. I'm just going to try to draw scalars 0, 1, 2. Okay, then there is 7 and 8, 9, 10, 11. Right at 7 will be neutral, and everything before 7 would be acidic. The number gets lower, and everything after 7 is basic, or we say alkaline. So if I say that a solution has a pH of 2, we know they fall under the acidic scale, so they are quite acidic. So if you go further down the scale from 6 to 0, 0 being the most acidic and 6 being the least acidic. And on the alkaline scale, 8 will be the least alkaline and 11 will be the most alkaline. Right here. So we know what a pH is. Now, some enzymes, they work great in neutral or acidic solution, and if an enzyme is meant to work in acidic solution and you put it in a neutral solution, it won't really work best. Let me give you an example. Protease. It's a protein enzyme. The ones who work with proteins. Protease works best in acidic solution. So protease would prefer a pH of 2. Next up, number 5, they are a catalyst. We all know that. Number 6, they are specific. One kind of enzyme only works on one kind of molecule. They do not work with others. protease works with protein, amylase works with starch. You do not see amylase working with protein ever. Now I have drawn this diagram here. We can see this being the enzyme, and it has got two active sites, A and B, and right above it is the substrate we have right here. You can see how the shape is quite complementary. It can fit, and if it does fit, it will form, it's supposed to fit, it will form an enzyme substrate complex. But right here is the same enzyme but with a different active site shape. If you see, it no longer fits. We say that the enzyme got denatured. This is what happens when an enzyme gets denatured. Temperature and enzyme activity. We know that most chemical reaction becomes faster at high temperature. The reason being is that at high temperature, they gain kinetic energy. It has more kinetic energy. This means that they move faster or move a lot. So if they do move faster, they collide with the neighboring molecules that's near them. Neighboring molecules many times in 1 second. So in 1 second, amylase will keep on hitting every different starch molecule that's next to it, and it will produce product more in just 1 second. So when you increase the temperature, it will only make sure your reaction is more likely to happen and also faster. Therefore, in short, rate of reaction increases. But there is a flaw in this, is that at really high temperature, they get damaged. The shape changes. And when this change, we do not use this word in our examination. Please do not use this word. We say they get denatured. Now you understood what I mean by denatured in the previous diagram that I have drawn you. So usually enzymes in our body, after 40 degrees Celsius, their active sites lose shape. Our substrate won't fit on our enzyme anymore. So above the 40 degrees Celsius, reaction will slow down. Now I have another thing that I want to explain is an optimum temperature. Optimum temperature is the temperature that an enzyme works best. The temperature an enzyme, why do I get spellings wrong, works best or fastest. So I would say, like I said, 37 degrees Celsius. After 37 degrees Celsius or after 40 degrees Celsius, reactions will slow down. So, right, this is the graph. As you can see on the y-axis, the temperature is increasing from 0 to 70, and this is the activity on the y-axis, how good it's becoming, how fast it's working. So we can see as the temperature increases, the rate or how fast it's working is getting more and more and better up to the point that they're really best at 40 degrees Celsius. After 40 degrees Celsius, they get denatured. It just becomes useless and the reaction slows down. And then you don't have more products. And after 62 degrees Celsius, you'll see you need to find another enzyme. If this happens in humans, it's going to be deadly. pH is also another factor. A pH also affects the shape of an enzyme. Most enzymes, they work best at neutral, say 7 pH 7, they don't change shape. But if you put these guys who work best at neutral in an acidic condition or solution, again they get denatured. denatured. At that time, your enzyme, like I said, cannot be restored. It becomes useless. I'll give you an example. Protease, they work best in an acidic solution. So acidic solution of pH2 is optimum for it. If it is like that because the presence of acid in our stomach makes the environment in our stomach really acidic, and protease has to be there to break down the proteins in the food that we eat. So that's how its nature goes. So I believe I've covered everything in this chapter, and I hope you understand. If you have any doubts, please leave it in the comments below. And the part 3 video will be some questions and exercises that I will be doing, and some of them for you to do it on your own.